We're going to introduce lesson 4.5 and we're going to start analyzing the graphs of polynomial functions. So in our previous lesson, we understood the ideas of what the degree does to our end behavior and how the leading coefficient affects whether we end up, down, or start down. So we're going to keep that in mind as we begin graphing these polynomial functions. Now, when we start this lesson, we're just simply going to use a chart. So for today, I'm going to start by giving you the chart. In our future lessons, we're going to have to figure out where to start that chart to graph our polynomial functions. So for our first example that you see on your skills practice guide, we have the polynomial function x cubed minus 3x squared plus 1. Now, before I dive into this problem and get started, what I want to understand is how the ends of my graph should look so that I know how far to start to the left and how far to keep going to the right. So you can see that this polynomial has a degree of 3. And its leading coefficient is 1. Now, from our table that we talked about yesterday, that means that our ends are going to be opposite because it's an odd function. And because the leading coefficient is positive, it's going to start in the negative direction and it's going to end in the positive direction. So that little table is going to be helpful to understand how far we need to graph. All right, now what I want you to do real quick, if you need to pause the video and do so, you may do that. So what I want you to do is take these table of values, so you can see that there's 7 of those, and I want you to input them into the function, and I want you to find f of -2 and f of -1, f of 0. So take a minute and calculate those results, and when you come back, you can check with me. So my -2 gave me -19. F of -1 was -3, f of 0 was 1, f of 1 gave me -1, f of 2 gave me -3, f of 3 gave me 1, and f of 4 gave me +17. So what I want you to see here is at the ends of the graph, the beginning graph starts at low numbers, and the end of it finishes at high numbers, precisely what I wanted it to do, understanding that end behavior information. Okay, so now I'm going to plot this. So how do I plot -2, 19? Well, I know it's going to be way down here somewhere. So I'm just going to approximate that. Then we're going to go to -1, -3. So this is the first point you're going to actually see on the graph. 0 is going to go to a +1, 1 to -1. 2 is going to plot at -3, 3 is going to plot at +1, and 4 is going to plot all the way up here at 17. Not going to quite reach it, but I know that I need to end up in that area up there, as well as starting down here. So now I'll take that graph, and I see a lot of points kind of scattered around, so I want to make sure I move from left to right to plot those. And then I'm going to connect those points. So I'm going to continue to move my graph left and connect those points as I move to the right of my graph. And I'm going to finish way up here, headed towards positive infinity. All right, so this is what my polynomial graph looks like for this cubic function specifically. You can see now it asks us to determine the consecutive values at which the real zeros are located. Now, because they're falling in between, we're not going to give the exact value. We're going to say the x integers that it falls between. So we're going to say that the real zeros are located somewhere between -1 and 0. The second one is going to fall somewhere between 0 and 1, left to right, always left to right. And then the third one is going to fall between 2 and 3. All right, and the last thing that we want to find is our relative minimums and maximums. So our maximum points are always going to be the points that are kind of at the top of the mountain, because by definition, a relative max is that the points in the area to the left and to the right all fall below. Doesn't necessarily mean it's the highest point in the graph, it's the highest point in any given area. So if I zone in this area here, you can see one of those peaks or a relative maximum. So I'm going to say that I have a relative maximum approximately when x is about 0, because it might not hit that exactly. It might hit it at 0.1. It might hit it at -1/4. We're not sure exactly where it hits that maximum because we haven't plotted every point on that graph, just these integer values. All right, as I explained the minimum is just the opposite. It doesn't have to be the lowest point in the entire graph. It just has to be the lowest point in an area, meaning that all the points to the left and to the right of it is above it or higher. That's what makes a relative minimax. So these are relative extreme values, the mins and the maxes. Okay, and in this graph, we can zone in right here to find our minimum, and we're going to have a relative minimum when x is approximately 2. We don't know if that's exact, but we're going to just say approximate at this time. Okay, so I'm going to go to number 5 on your skills practice worksheet. And you can see there that the function is x to the 4th minus 2x squared minus 2. Now, once again, I'm going to dive in and understand what my ends should look like. So my degree in this polynomial is 4, so we know that that is even. We should also know that that means that it's going to end in the same direction. My leading coefficient for this problem is also 1. So that means that my ends are going to both end in the positive direction. So when I'm looking at values to the left and all the way to the right, they should be pretty high values. So take a minute and pause this video and go ahead and input all of these points into that function. So -3 gives me 61, -2 gives me 6, -1 gives me -3, 0, -2, 1 gives me -3, 2 gives me 6, and 3 gives me 61. So you can see that these ends are both very high numbers, and that's what I want them to be. I want it to go left and right far enough till I'm reaching very high or low numbers according to my degree and my leading coefficient. So now I'm going to plot these points. So -3, obviously I can't get to 61, but it's going to be way up here. I'm going to put my arrow up there. -2 is going to go to 6. -1 is going to go to -3. 0 plots at -2. 1 plots at -3. And 2 plots at 6. And of course, 3 is going to plot way back up here at 61 where we can't see on our graph. So now I'm going to go to my furthest left point and start connecting those points left to right. As you can see, I have this little bit of a W shape in this quartic function. Now I'll be looking for where do we cross the x-axis. So where are our real zeros located? So the first one's going to be here, and the second one's going to be here. So our real zeros are falling between again. I'm going to say it's between -2 and -1. And you can see here that's where we're crossing from positive to negative. So I have to be hitting the x-axis somewhere there. And then it's going to cross again between 1 and +2. And again, that's where it crosses back from negative to positive values. So I have 2 real zeros. I don't know the exact values, but I know about where they are located at this time. Okay, now let's talk about the relative mins and maxes. So my relative minimums are going to be at low points on my graph. So I actually have two minimums in this graph because I have two valleys on there. So I'm going to say my relative minimums are going to be at approximately, that point is going to be at x equals -1, and this one's going to be a +1. So my relative minimums, I have two at approximately -1 and +1. And then on this graph, you can see it's not the highest point in the entire graph, but it is the highest point in the area. So this is going to be called a maximum here. And I'm going to have a relative maximum at approximately 0. All right, so this is just the beginning of our sketching of polynomial functions. When we continue through this section, eventually I'm going to take away that table and you're going to have to identify how far left to start and how far right to go. All right, what I want you to do is continue this skills worksheet and we will check those tomorrow. I hope you all have a great day.